Why do propellers sometimes destroy themselves without hitting a single rock? Because of cavitation, tiny vapor bubbles form where pressure drops, then collapse when pressure rises again. That collapse hits the metal like millions of microscopic hammer blows. Think of it like bubble wrap, except each pop is a pressure shock, and it's happening thousands of times per second right on the blade. To see why this happens, zoom in on one propeller blade moving through water. One side of the blade is the pressure side, pushing water back. The other side is the suction side, where the flow speeds up. When a fluid speeds up, its pressure can drop. If the local pressure drops far enough, down near the water's vapor pressure, the water can literally boil at that spot, even though it's cold. Not boiling from heat, boiling from low pressure. At first, cavitation looks harmless, a milky cloud of tiny bubbles clinging to the blade, often near the leading edge, the midcord, or the tip vortex. But the real damage happens a moment later. As the blade rotates, those bubbles get carried into a region of higher pressure. Suddenly, they collapse. And they don't collapse gently. A collapsing bubble can form a high-speed microjet that shoots toward the metal surface, plus a shockwave that slams into the blade. The force is concentrated in a tiny area, so instead of one big hit, you get endless needlepoint impacts. Do that long enough and the surface starts to pit. The pits create roughness, roughness triggers more cavitation, and now you've built a feedback loop that chews the blade faster and faster. There are different flavors of cavitation, and they don't all look the same. Tip vortex cavitation forms a spiral, like a corkscrew of bubbles trailing from the blade tip. It's common when the blade is heavily loaded. Sheet cavitation looks like a smooth, attached bubble blanket on the suction side. When that sheet breaks off, it can become cloud cavitation, and cloud cavitation is often brutal because the collapse happens in bursts, like bubble storms. You can usually hear cavitation before you see it. It often sounds like gravel or sand blasting the hull. That noise is literally pressure pulses and bubble collapses. And it doesn't just erode metal, it steals performance. When the blade's surface turns into vapor pockets, it can't grab water properly, so thrust drops, vibration rises, and efficiency tanks. So what triggers it? High RPM, too much pitch, sharp loading changes, and operating near the surface can all push pressure too low. Warmer water makes it easier too, because vapor pressure is higher, meaning the water boils at a higher pressure than cold water. Damage often concentrates near the trailing edge and tip region where pressure swings are intense and vortices form. How do engineers fight back? One approach is reduce blade loading, lower RPM, adjust pitch, or use a larger diameter prop to spread the work over more area. Another is change blade geometry, more blade area, different camber, skew, or cup to avoid extreme low-pressure pockets. Duct props, like a quart nozzle, can also help in some cases by changing the flow and pressure distribution. And materials matter. Some alloys and coatings resist pitting better, and polishing the surface reduces nucleation sites where bubbles start. But here's the harsh truth, cavitation isn't a rare glitch. It's a design limit. If you demand too much thrust from too little propeller, the water will break, and the bubbles will punch back. Next time you hear that gravelly roar from a boat under acceleration, ask yourself, is that the engine or bubbles attacking metal? What machine should we break down next? Ship propellers, water pumps, or turbine blades?